Welcome. I'd like to thank you for listening to this decision support system presentation that I created, detailing a online career search tool to build effective search queries in finding jobs online. The current process of career development is kind of 4 steps. First being just attending university, second graduating from university, a third mysterious step, and then fourth, magic happens and we get a job. Optional things we can do during education is internships and certifications. That step 3 is finding a job. The 5 basic places where we can find jobs: help wanted signs, job fairs, classifieds, online postings, and employment services. I'll be focusing on the internet sources of jobs. That has both increased the number of applicants and applications that HR departments can read and people can send in. But because of that, the problem has scaled in that HR departments now have thousands of things to read through. And applicants have hundreds of jobs that they need to be able to figure out where they're going to put their time in to applying for. I'm going to be using Indeed.com, which solves my web mining problems as a premier search engine for jobs. It's a really good search tool, but there are some things that we need to learn about leveraging this, being effective in this, using this tool. Better understanding the problem, do we know what company, or can we assume that companies know what they're looking for? I feel the answer is no. There's a lack of communication between HR departments and the managers. And so they're usually a vague list of very particular technical things that describe a job. I would also say no to, can we assume we know what we're looking for? Being trapped in university for 4 to 6 years, we don't really know what the demands are, even though we can have good guesses. We also have no idea what the job titles are or a bunch of other things. So I think we could really use with a lot of help. Using a search engine, especially Indeed.com, if you use generic terms, we'll end up with a giant pool of possible jobs that we can never search through, and especially most of them will be false hits. It's stuff we can't use. Using overly specific terms will not return very many results, or maybe none at all, depending on the scope of your search. They will also return jobs that we basically may not have any experience for. One favorite example of mine is searching for math across the United States. Ends up with 5,000 Pizza Hut delivery driver jobs and 800 dog training jobs. My personal experience in searching the web has showed that you really need that the choice of words really affects the search results. Just querying the degree that you have. So me, I will get an industrial engineering degree. If you just do that, you'll miss a lot of very relevant jobs. Again, because HR departments may not know what degrees are applicable for the position that they're looking for. It's essential to use the advanced search options to further prune and tailor the results. The next slide will show what happens when I change my math search to take out all the teacher jobs and force analysts to come up with the title. And we can see we have no more Pizza Hut drivers. Number 1 is data analyst. Number 2 is business analyst. So these are very highly relevant to my degree, something that I would actually choose, probably apply for if I was going to remain in America. My goals for this project is to address the lack of an intelligent tool for job search. I want to give students a starting point that makes no knowledge assumptions or doesn't ask the student of any analysis themselves. All I want them to provide me is some raw data describing their school experience. The third goal is to use Python to implement this project. To do this, I will be using text mining tools and text mining techniques. First, I want to create a dictionary of words based on the supplied course descriptions. From there, I'm going to measure how many times each word occurs in the course description. And then I'm going to use that list of words and find out how many jobs are related to an individual word from the Indeed.com website. Using those 2 statistics, I'm going to create clusters, and the clusters are going to relate to a rank and size. So the highest rank for course description will be the word that occurs the most number of times, and the highest rank for hits will be the jobs that return the highest number of jobs. I figure that then I will combine these two frequency ranks and hit ranks to be able to identify the most relevant words that describe the degree and the needs of the employers. I'm going to be using Python and R for some data exploration, and specifically a Python module called NLTK to use some natural language things. This is what the raw data for class descriptions looks like. This text document is 47 lines, each line representing a class that I've taken in math, stats, computer science, industrial engineering. Not very much has been done to it, except I have removed the prerequisites and course credit information and other stuff that is more administration side in each course. To process this data, I use regular expressions, the RE module. First, I split the documents into lines, and then each line I split it into words. The third step is to remove the stop words, English words from the NATK module, and then also some school words. I went and looked in Excel at what words also frequently occur that have nothing to do with any kind of content. So words like includes, including, use, using, introductory, introduce, those words I put into another document and eliminated them from everything. Fourth step was to lemmatize the word. I think that's a word, I'm not sure what it means, but it's the method from the NLTK module. It basically takes as plurals and changes them to singular, so it standardizes the corpus. So I end up with a couple arrays of words, and then I create a dictionary based on a sorted set of these words, and I count how many occurrences there are. The next step was then to use those list of words and pull the Indeed.com servers for job data. To do this, I needed to use URL module and an XML parsing module to be able to get the particular number that was relevant for my project. I broadened the search not just only using American data, but also Canada, Great Britain, Australia, major English-speaking countries. Descriptive statistics, a total of all job hits across all words in all countries got up to almost 7 million. I ran a correlation chart to see how related those job statistics were with each vocabulary. So you can see U.S., Canada, fairly related at about 7%. Great Britain and Australia, less related to U.S. than Canada. Canada almost being at 90% related to Great Britain and Australia, and then Australia and Great Britain being almost identical. We can also see the breakdown of job search volume. So the U.S. was 65%, Great Britain 26%, Canada 6%, Australia 3%. The next part was to cluster the data, and I used R to figure out the size of the clusters, the K in the K-means. The drawback of the R module, the R function, was that it returned slightly randomized clusters, so they changed every time I ran the function. So I used it basically for exploration, figuring out how many clusters I needed, and then I built my own K-means algorithm so I could have repeatable experience. I chose the 5 clusters for frequency data, 7 clusters for hit data, which ends up with 35 possible unique clusters. I then combined the cluster rank by multiplication for that overall score. You can see analysis had 4 times 3 for 12, and management 1 times 5 for 5. These are my clustering results. 565 words were analyzed. Anything that was 0 was deleted. So what was a word? A word like methods or business, while highly popular or highly represented in job data, didn't show once in the job description. So it ended up with a score of 0, which was fine because I don't want words that pull in useless jobs. So 36 words survived. I recorded the clusters, 2 types, a colored cluster, which represents the breakdown, the differences in the scores, and then the combination, which is a more unique thing. So we can see that analysis and service both scored 12, but how they got that 12 was in little different ways. I found that the resulting data was really interesting, that it works so well to pare down the words from 565 to 36. And then if you look at each group, that they're quite related. My degree, industrial engineering, engineering, control, product, financial, quality, project, planning, and software. It's like, you know what, that's definitely something that I can use. Those automated results are very trustworthy. Using these words in the search, put them back in Indeed, combined by using the or at least one of these words, so I didn't exclude anything or overly penalize a particular job for missing just one or two words. These are results across the entire US. You can see them down there. Analysis service, I just lump them all together. So I get mathematical statistician, supply chain, some analyst position, process for improvement, 2.5 million jobs in the last 30 days. So these are quite relevant, and I'm happy in that this is what it turned out. The top 15 job titles just in Oklahoma. So I got data analyst, application developer analyst, 25,000 jobs in the last 30 days. Pretty good. California, using analysis, data, project, or software, 150,000 jobs, and you can see their titles are, I would say that they're very relevant. Well, how does this compare to my own search terms that I've built by myself? You can see them there on the screen. That they're basically composed on my interests and what I found in the iterative process of searching, weekly for a couple of years now. The minuses are basically take out teacher jobs. I found those ones really pollute my results. Examples of stuff that I get using that in America: high frequency quantitative analyst, pricing optimization, capacity analyst, jobs with Facebook, ESPN, Bank of America, Planet Hollywood. You can see that it was only 16,000 results. So I've been able to really turn down the amount of data that I have to go through and measure. Future things that you could do with this: use text mining techniques that use term document matrices, leverage association minings to maybe draw in data from resulting job titles when I search this. It would also be helpful to do some supervised learning with a human being, like, well, I like this job is not good, and to be able to automatically maybe generate a list of words that are negatively correlated with jobs. A summary of tools that I've used: regular expressions to process raw text, protocol for URL communication, a parsing of XML data, the natural language toolkit to help me with some language-related problems, and then a k-means clustering to be able to rank the groups and be able to find the most effective words. When I learned, Python was really good. I had a really easy time developing in this language. It was very useful to use R to find good answers, but I didn't necessarily want to use them in my production tool. My scoring method worked out really good. I mean, 565 down to 36, or 36 words. That worked out real well. And data sources with APIs and using cross-platform type technology really accelerated the ETL stage. Thank you for listening to my presentation. I hope you learned something and that it offered some inspiration to some problems that you may tackle yourself in the future.